rational and irrational numbers. Yes. I'm doing this. I'm doing the first chapter, rational and irrational numbers. I had completed till question number 6 most probably in the last video. Okay. Now question number 7 is saying that prove that root 5 is an irrational number. Okay. Hence show that minus 3 plus 2 root 5 is an irrational number. Now this type of a sum, I'll just give you a hint of it. Basically you can do at home. If you question, sorry, I usually don't question. Hold on one second. Question is saying prove, first you have to prove that root 5 is irrational. Root 5 is irrational. B. Okay. Root 5 is irrational. Then after that you just have to do this, that irrational, IRR, rational into irrational is always irrational. So that is 2 root 5, that means it is irrational. Okay. Then after that you have to show that minus rational plus irrational is always irrational. If I tell you, I'll just give you an example of this. Okay, if I just want to show you something. Let's say I would take an irrational number. If I take an irrational number root 3, so what is the value of root 3 in the calculator? I want to tell you. The value of root 3 is about 1.732050,808, and then it continues. So this type of a number, so if you do minus 1 plus that 1732050,808, and then you continue with that. So this basically becomes what? That's greater, so it becomes 0.732050,808, and it will continue from there. So you can see that is also an irrational number. That's what I said. So minus rational plus irrational will always give you an irrational. Okay. That's the logic. Okay. Now we are not going to discuss much on this. Okay, you can do the question number 7 and the question number 8 that I can see at home for homework. Okay. So we are going to basically start the next part. Okay, we are going to start the next part of this chapter. Okay, we are going to start the next part of this chapter. Let's continue. Let's continue on to the next part of this chapter, students. So we now we are going to learn how to locate an irrational. Now let us show you without. I know what it is. Now we will learn, the next topic we will learn how to locate an irrational number. Irrational number. How to locate it? Where would you locate it? On a number line. On a number. If you see students, I want to show you something. Okay. You see that in the first video I have shown you that we start with natural, then we go to whole, then we go to z, integer, then we go to rational cube, then we go to irrational b, and then the last one is a real number. After this also there is another number, but that we will discuss in class 11. Okay, so you see all these numbers down from, all these are all real numbers. Okay, they are all covered by real number set. This is all real number. Okay, so all of these can be plotted on a x-axis or on a y-axis, either here or here, not anywhere here, not anywhere there. Okay, you cannot plot the real numbers anywhere here. You have to plot it either on the x-axis or on the y-axis. The other number is called a complex number C. Okay, that is basically plotted somewhere over here, somewhere over here. Okay, but we are not going to talk about it, I told you. Okay, now look very carefully. We are going to plot an irrational number. If you can plot a rational number, say 2 by 5. How do you go 2 by 5? This is 0 by 5. This is 1 by 5. This is 2 by 5. This is 3 by 5. This one is say 4 by 5. Okay, and 5 by 5 is 1. And 0 by 5 is 0. So you need this point basically. Okay, this is the point that you need. Okay, when you Now we learn how to locate numbers like root 3, okay, root 2, root 5 and all that. Okay, we might not learn all of them because most of them are like easy to locate, very very easy to locate. Now you must be wondering, sir, how can I locate root 3 that you just showed me as 1.7320 something 50808 and then continue. How am I going to locate this on a number line? Then I'm not going to locate that on a number line, but I'm going to locate root 3 on a number line. Okay, so let us start. I hope you are understanding what I'm trying to say. We can locate all real numbers on x-axis or y-axis. So x-axis is the number line. Okay, either y-axis is the number line or x-axis is the number line. If you change the y-axis, we put it down here, that becomes the x-axis. Okay, so both of them are real axes. So I'm going to rub this off and I'm going to start show you how we are going to draw, how we are going to plot like root 3 or something like this on a number line. Okay, so let's start. So I'm going to take the example that is in your book and try and show you how we are going to plot it. Okay, there's going to be a lot of construction over here, my students. Okay, so you might want to take out your ruler, your compass and your protractor. Okay, these are the things you want to take out: the ruler, compass, protractor. Have a pencil ready also. So I'm going to show you construction, although I don't have the instruments to construct, but I'm going to show you how to do it. Okay, don't worry. So we are going to locate example. I'm going to show you an example 1. Example in your book. Root 30. We are going to locate root 30. Okay. Now just think that 30 can be written how? Square of two numbers. Let's say if I want to write 30, then I can write it as 9 plus 4. Isn't it? 9, 10, 11, 12, 13. But if I want to write it as, these two are both square numbers, so I write 3 square plus 2 square. Okay, so that becomes 30. So if I write this like this, 13 is equals to 3 square plus 2 square. Okay, and I put a root over on both of them. If I put a root over on both of them and again square it and again square it, okay, you will see this h square is becoming b square plus b square, isn't it? Look at it, that root over is gone. I kept this one here. This h square, if I take this h as root 30, so h square is always b square. B square is equals to 3 square and plus b square, that is equal to 2 square. Okay, so b is 3, b is 2. Okay, so in that concept, using the Pythagoras concept, students, I'm drawing this triangle this way so you understand. So my perpendicular is 3 and my base is 2. Then what is my hypotenuse? So h square is equals to 3 square plus 2 square. So h is equals to root over 9 plus 4. That is root 30. Okay, understood, students? Try and understand. Okay, so let's continue. Now how are we going to plot that? That's the problem. So get ready. Okay, I'm rubbing this off. You already know what we are doing. Get ready. Let's start. Draw a long straight line in your exercise book. Draw a line. Name it. PQ. Name it. Any length. Any length. With your ruler. Put your ruler. Put your ruler. Draw. Now, make a point over here as A. Make any point A. Make any point over here as A. Now, take a point B over here such that, what did we take? What did we take 13 as? 9 plus 4, that means 3 square plus 2 square. Okay. So, take this as 3 unit. How much, students? 3 unit. Now you will be surprised, sir, how can I take 3 unit in my ruler? Now just see, this is your ruler. Suppose this is your ruler. starts from 0 here. 1, 2, 3, 4. This is the fifth one. 1, 1, 2, 3, 4. This is the 2. 1, 2, 3, 4. This is the third one. Okay, now look very carefully. Now start from here. Suppose you take this as 3 centimeter, or you can even take 6. 1, 2, 3, 4, 4. 1, 2, 3, 4, 5. 1, 2, 3, 4, 6. You can take the whole thing as 6 and name it as 3 unit. Doesn't matter. Doesn't matter. You can take 6 centimeter also and name it as 3 unit. Okay. So you see there are two going at a time. So you know what to do, because the next one you will take 2 units. So 2 units will be this much of the 3 units. So you're okay with it, isn't it? You're okay with it? Huh? So you take like that only, something multiple of that. You multiply that 3 to the 6. That's 2 to the 4. One part is left. So this is 3 unit, students. Now you draw, put your protractor here. Put your protractor here. Put your protractor here and draw a perpendicular. Although this didn't come properly, when I draw it. Don't worry, I'll draw it. Draw perpendicular, not that big, 2 units. 2 unit perpendicular, students. Hold on, don't draw anything, hold on. Let's make this proper. Let's keep this here. There you go. Somewhat okay. So this is 3 unit. I'll take it a little shorter. Because I want to make it like 2 units. Now on your copy A, B. Okay. Take that point as C. Okay. Now in your copy, students, you will see that this, when you take 3 centimeter, if you take 3 centimeter, you can take 3 centimeter. Then you take 1 centimeter this one. Okay. Then you take 1 centimeter. It's one part left. 3 centimeter, 1 centimeter, 2 centimeters. Okay. No, don't take 1 centimeter because there is only one part left. This 3 and take this as 2. Okay, because that is 2, no? 3, 2 take in your copy. If you take this as 6, then take that as 4. Okay. So 3, 2. I'm trying to make this 3, 2. Yeah, there you go. Something like that. Let's put this point much more this side. Okay. Then probably look like that. So this is 3 parts. Say. That is 2 parts of it. Okay. So that, students, is 2 unit. Okay. Now according to Pythagoras, when you join this C point, that is, when you join that, according to Pythagoras, this, students, is root over of 30. Okay. If you look over, or if you do Pythagoras, then you get this as root 30 unit. Okay. Now what do you do? Now is the main thing. Now what do? You put your compass point here and you put a pencil over here, take the whole thing, measure the whole thing, and from here you just drop it over here, and that is basically root 30 unit. Unit, student. No unit is given over here. Centimeter and all is not given. But make sure, like, when you're drawing it, okay, you draw it in such a way that, where did I write the root 30? When I came this side, I realized, what is that? Sorry about that. Root 13 unit. Okay. Now what happens over here is, when you notice this, this is the root 30 unit, but make sure you take this properly. This is the main thing. If you don't take this properly, then you will never get that. Okay. So can we go on to another question? So let's go on to another question. Okay. Let's go on to another question, students. Hold on, let me just open the window close to it. Give me a second. Okay. Alright, students, you understanding? Now let's go on to the question. Okay, let's go on to the question. But before that, I want to show you something else about this locating thing. The root 3, how would we locate something that is not a square of 2 but something different, like root 3. Let's say example number 2. Okay, I want to locate root 3. So how am I going to do that? How am I going to locate this root 3? This root 3 is basically root over of root 2 square plus 1 square. Check it out. Root 2 square plus 1 square. Now you must be wondering, sir, then I have to first plot root 2, and then I have to do root 3. Yes, you have to do that. Okay, first you have to plot root 2, and then only you can plot root 3. So let's start doing that and try and understand how it is done. Okay. So make the same thing, a straight line, MN. Okay, so put a point A over here. Now first you have to draw root 2. Okay, so take a B over here, say 1 centimeter, or say 2 centimeters. So if you have taken 2 centimeter, then here also the point C will be 2 centimeter. And how are you going to draw that? How are you going to draw that perpendicular line? You already know. You put your protractor here and you will draw that perpendicular. You will draw that perpendicular. So this is 1 unit, students. This is 1 unit, and obviously this is also 1 unit. So this is the base and the perpendicular. So now when you draw this becomes your root 2 units. That's a hypotenuse. Root 2. Now you don't have to draw the root 2, you have to draw the root 3. So what you do from here is you extend this line, extend a little bit more. Okay. So A, B, C, let's make it D point. Suppose this is the D point. Hold on, don't extend it so much, okay? Because we got root 2 already. Now we need another 1. Okay. So we will get another 1 because we haven't got the perpendicular. You can extend, no problem. A, B, C, D. You can extend this part a little bit. Okay, students. Now we have to draw another 1 unit. See, I've drawn 1 unit plus 1 unit, that is root 2 unit. Root 2 unit is over. Now we need another 1 unit, students. So we are going to draw a perpendicular by keeping this as the baseline. By keeping this AC as the baseline. Keep AC as the baseline and draw perpendicular. So your tractor would come something like this. Tractor would come something like that, and your 90 degree will be here somewhere. Okay, so if you draw the 90 degree from here, somewhere like this. Okay, now you will need only 1 centimeter, so it will be small. 1 unit, I will be a bit small. Okay, understand? So this is your protractor. This is your protractor. This is your 90 degree. Other degrees are here. That's your 90 degree. Yeah? So you have to make a perpendicular over here, and you have to make a perpendicular over here. So that's your 90 degree. Now this and this has to be same. Okay. So just make sure that that's 1 unit over here, not less than that. So measure it with your ruler. Now when you join these two, so it's a 1 unit here. So that's C, A, B, C, D is gone. E this is. Okay. So that's a 1 unit. Now you put your point here, compass point here, and you put the pencil over here. And then when you draw the line here, and you get that as root 3. You get this as root 3 unit. I hope you are understanding what's happening. Okay. If you don't understand, definitely let me know. Okay. You see, notice it. Notice what's happening. First you made a 90 degree over here. Now you have made a 90 degree triangle over here. Now with this as a base, you have to make another 90 degree triangle. Otherwise you won't be able to do Pythagoras. Right? So where you made another 90 degree triangle, and this you know the measurement root 2 already. Then you need another 1 square. So that's 1 square. 1 square means this square. So that's it. Whatever you take in your ruler, that's your problem. Okay. If you want to take 1 centimeter, take 1 centimeter. If you want to take 2 centimeter as 1 unit, you're going to take 2 centimeters as 1 unit. Then accordingly you have to count. If you have 2 centimeter as 1 unit, then if you have 6 centimeter, then you have to count 2, 2, 2. That's 2 plus 2 plus 2. That's 3 units. Okay. Okay. So let's do something from the exercise, shall we? Rubbing this off, students. I hope you have understood. If you didn't understand anything, let me know. I will explain it. And how to let me know, you know better than me. Okay, I don't have to explain that to you. Anyways, I'm rubbing this off. So let's go on to the exercise, students. Okay. So I got the book over here. I'm going out of the screen. Sometimes I will go out of the screen because I'm looking at the question over here. But that doesn't mean that I'm not with you. Okay, you can listen to me. Just look at the board. Okay. Locate root 10. Let us locate root 10, students. What exercise are we doing? Exercise number 1.3. Exercise number 1.3, question number 1, locating of root 10. So root 10, how would we write that, students? That is 3 square plus 1 square, 339. That is 9 plus 1, that is 10. And basically root over only. Anyways, just write that 10, don't write that root over here. So that's 10, that is that. Okay. Write it, whatever it is. Okay, now it's fine. That's the basic logic. Okay, that's 10 actually. 10 actually. Now we're gonna locate. Now we're gonna do this and this. So if you're taking, students, if you're taking 2 centimeter equal to 1 unit, then you will have to take another 3 of them. That is 2 plus 2 plus 2. That is 2, 3, 4, 5, 6 centimeter equals to 3 units we have. Okay, students, so I hope you understood the measurement conversion. I hope you are understanding the measurement conversion. Let me show you how to do. Okay, start. Let's start. First thing, students, there's nothing, no point by point, there's nothing to write over here. Okay, some people, I wouldn't say they are wrong. Okay, none of the mathematics teachers are wrong. Everybody is perfect in his or her own way. If you're writing the points, if you're writing it point wise, what you're doing is you're remembering mathematics, and mathematics has nothing to remember, my friends. If you're going to remember a formula 10 times, okay, then you actually forget where to use it. Understood? You're not concentrating as to where to use that formula or how to solve that sum, even when you don't remember the formula. Okay, sometimes you know how to make it. So we'll get into all that, don't worry, because class 9 has a lot of geometry in it. So you cannot write the geometry point wise, you can understand it point wise. You cannot write it and learn it point wise, then learn it this way. This is the way it's supposed to be. So that's not possible. So what do we do? First thing that we do is make a line and mark it, the alphabet that you love most or you like most. Okay, it doesn't have to be that you have to write the alphabet I'm writing, anything you can write. So I'm writing an A over here. Okay, and suppose I'm taking in my ruler 6 centimeter. So I would have a B over here, 6 centimeter. But 3 times 2. Let's take 3 times. If I take 3 times 2, I'd probably have it. Let's go more here. This side A. Okay. Probably have it here. Yeah. B. That is how much? 3 unit, students. That's 3 unit. Yeah, we are supposed to take B3 and B1. Then only you get the hypotenuse. Now we need to take 2 centimeter. If you've taken, students, if you've taken 2 centimeter, then from here to here will be your 2. From here to here will be another 2. From here to here will be another 2. Now I didn't make it like curly bracket. I was trying to make it like that, but it didn't come out. So I hope you understood the basic concept of it. So now what do? Now we make same way. Put the protractor. Here's your protractor. Here's your 90 degree. There we go. That's 1 unit, students. 1 unit. If you measure, that's 1 unit. 2 centimeter. 2 centimeter you will take. 2 centimeter equal to 1 unit. That's what you are going to take. 2 centimeter. That's what I am taking actually. A, B. Put a point here. C. That's your 90 degree. 1. I can draw the protractor with red marker, differentiate, that's your 90 degree. Here's your perpendicular to show that's your 90 degree. That's it, it's done. What do you need to do next? Next you need to do is just join this and put your compass point here, put your pencil here, and there you go. That's your root 10, because you have a root 10 there, and that's how you plot it on the number line. And the number line is what? Mn is the number line. Basically you must be thinking, why is Sir drawing Mn, then taking AB? But Mn is the number line. That is the x-axis. Start from 0 via M, ends at infinity. Doesn't end there, ends at infinity. So there you go. When you draw it in your copy, the students, it will come very nicely. Okay, so you don't need to worry about it. Okay, the next question is root 79. I'm absolutely sure all of you can do. Just give you how to split it. I think you guys know how to split it. How does it go? 70. Take out a square number, 4. If I take out 4 now, what do I take? 9, 10, 11, 12, 13, 14, 15, 16, 17, 6, 7, 8, no. What is it? 16. Huh? 16 plus 1, students, that's 4 square. That is 4 square plus 1 square. So P is 4 and B is 1. Hope you guys can do it. Okay, take 4 parts from here, 1 part from here. You can take 1 part from here, 4 part from there, doesn't matter. You can do it the other way also. This is 1 part, 4 part here. Like I could have taken 1 part here and 3 part here. Okay, and draw the locate it on the number line. Okay. Now, students, we go on to the second question. Root 17 is your homework. That comes in your 10%. Easy to do. I showed you how to split it. Do it at home. Please don't leave a question like this and don't leave that contradicting. The proof by contradiction. Don't leave it. Do it and come. You get full marks. Try and understand. Do it and come. If you don't understand it, you ask me again. Let's start with the second question, students. Second question, my students, it's saying that write which is a terminating decimal. Now, before doing the second question, I just want to let you know. I want you to write this note. Write a note. When the denominator of a fraction has factors in the form 2 to the power n into 5 to the power n. Okay, it has factors in the form 2 to the power n and 5 to the power n. Then that type, it's from there, okay? From there, then that type of fraction is called, that type of fraction is called a terminating decimal. Okay. Look, students, if you can write the denominator, okay, in terms 2 to the power n, 5 to the power n, then that type of a fraction is called a terminating decimal. Let's take an example from your question only. Say 2 part 1. What is the 2 part 1? Part 1 is saying 36 by 100. Let's find the factors of 100. Denominator. Students, what is it? Denominator. 250, 225, 55, 51. Okay. So 100 can be written in the form 2 to the power 2 into 5 to the power 2. So you can see it can be written in that form. It can be written in that form. So what is it? So that fraction is a terminating decimal. This fraction is terminating. This fraction is terminating decimal, students. Okay. Understand it, what I'm trying to say. Okay. So we can write the factors in this way, then it is a terminating decimal. And we cannot write the factors in this way, then it is not a terminating decimal. Okay. So let's run this off and show you another one. Hope you can copy that. Going back. It's too warm today. Okay. And it's still under construction, so I haven't got the proper lines with the air conditioner or anything like that. But anyways, we can manage it. I can manage it. You can sit down in your home, enjoy yourself, watch the video. Doesn't matter for me. I'll just do my work. Anyways, part 2. We do the part 2. 8, 4, 32, 32 plus 1, 33 by 8. Now do the HCF of 8. 2 4s are, 2 2s are, 2 1s are. Now what are you getting? 8 as in 2 to the power 3. No, you're not getting a 5. You're getting a 5. No, you're not getting a 5. So what are you going to say? Is that a terminating decimal or a non-terminating decimal, students? Let's say 33 by 8. 33 divided by 8. It's a terminating decimal. Okay, it's not a non-terminating decimal, but you're not able to divide. But then what to do then? What? There is a 5. You just didn't see it. 5 to the power 0. Just didn't see it. No. Did you? You didn't see it. There was a 5. 5 to the power 0 is what? 1? 1 is there. There was a 5. So that 2 to the power m into 5 to the power n, the m and m can be different. M can be greater than m or n can be greater than m. Anything is possible. Okay. So m and n don't have to be the same thing. Okay, and it can be 0 also because they belong to whole numbers. M and n belong to whole numbers. M comma n belong to whole number, students. Okay. That's it. Part 2 is done. This is a small thing, very small thing. Okay. So the other ones also you can do with saying without actual division. Perform the long division. It is same. Without actually performing the long division, state whether following rational numbers will have a terminating decimal expansion or a non-terminating repeating expansion. So it is the same way to do. If it's a terminating or a non-terminating. I told you the shorter one for part 2. Basically, the part 2 is just the longer one. Okay. And the part 3 is the shorter one. But you know the basic logic. So I think you can do it. Okay. So let's see what's the next part. The next part is the same thing. Question number 4, without actual division, long division, show that is a terminating decimal. Just do the HCF of the denominator, and if it comes in the power of 2 to the power n and 5 to the power n, then it is a terminating decimal. Otherwise, it is not a terminating decimal. Okay. Now I see 5 also. Write the decimal expansion of the following numbers which have terminating decimal expansion. So which are terminating, only those ones you have to write and you have to expand them. So let's just put 5 part 1 and finish this class off for today so that we can continue in the next video, next part. Okay. I don't want to hassle you so much. Okay, that's enough for today. So first we have to find out whether this is a terminating decimal or not. So 8, 2 4s are 8, 2 2s are, 2 1s are, so that's 2 to the power 3 into 5 to the power 1. Yes, it is a terminating decimal. So 8 is equals to 2 to the power 3 into 5 to the power 1. So answer is yes, it is a terminating decimal. So expand it. 8 2s are 16, 1 0, 8 1s are 8, 2 it was 8 2s are 16, 8 3s are 2s are 16. That's a 4, 8 5s are 4. So The answer is 2.125. That is 17 by. So if it is a terminating decimal, then expand it. If it is not a terminating decimal, say no, cannot be expanded. That's all. Okay, students. Hang in the heat. Sorry about that. Very, very sorry. But anyway, students, that's it for today's class. We'll continue in the next class, okay? And take as much as help as possible from math is possible. See you in the next one. Bye bye.